Hello, everybody, and welcome back. Welcome, I guess, to our final lecture. So the date today is the 30th of April, 2020. And our last section that we will be covering is section 5.4, and it's called Graphs. Graphs of the sine graphs of the sine and cosine functions. Okay, so first we need to kind of discuss what the domain and range of sine and cosine functions are. So if you remember back, we learned how to graph all types of different functions: polynomials, rational functions, exponential functions, logarithmic functions, and we always start out with finding their domain and range. So if we consider the unit circle, so remember sine theta and cosine theta, their input is your angle, right? You're inputting an angle. And remember, sine theta is equal to y over r, and cosine theta is equal to x over r. And r is always positive. So the unit circle, we just have the sine of theta is equal to the y value, the y coordinate, and the cosine of theta is equal to the x coordinate. Okay, so the x coordinate, or the nice thing about this is these are always defined, so you can put, there's no division by zero here, so you can put in any angle you want. So the domain for sine and cosine is negative infinity to infinity. Okay, so if we're just talking about sine theta and cosine theta, we can look at this unit circle here. And so if we put in 0, we get sine of 0 is 0 and cosine of 0 is 1. Right? That's this angle right here. And then we continue to do this. So if the sine of theta and the cosine of theta are the x and y values on the unit circle, then let's see, 1, 0. Then our sine and cosine values can never be bigger than 1 and can never be smaller than negative 1. So the range is negative 1 to 1 included. Okay, so that's just for plain old sine theta and cosine theta. So there's no constants being multiplied, or there's no, it's not 4 sine of 2 theta. It's just 1 times sine of 1 theta. Okay, so another thing we would always like to do is, where are the zeros? Zeros. So if I go back and look at my unit circle, if I wanted to find the zeros of the sine function, I would look for the places where the y value is equal to 0. So right off the bat, you could say that theta equals 0. If I put 0 in for sine 0, I get a 0 back. Then sine sine theta equals 0. But if I do theta equals pi, and I'm going to do it in radians here, then sine equals 0. So now what if I did theta equals 2 pi? Well, sine still equals 0 because that's all the way around here. What about theta equals 3 pi? That's one rotation and then another one back to here. So still 0. And this goes on and on and on. And in fact, it goes the other way too. What if I did negative pi? Well, that's up to here. And this goes on and on and on. So the zeros of sine theta are so n times pi, where n is an integer. Okay, and the same reason, the zeros of cosine theta. Okay, so the zeros of cosine theta, we need to, if I plug in pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so on and so forth, you get it. So it's actually the zeros of, the way you can express that is 2n plus 1 times pi over 2. Okay? So the zeros of sine are multiples of pi, and these are the zeros of cosine are odd numbers times pi over 2. Okay. So now that we've got the zeros, it's also we also talked about some even and odd functions a couple sections ago. So it turns out that the cosine of theta is an even function. And the sine of theta is an odd function. Okay, so briefly, remember what that means. That means that cosine of x, or sorry, I'll do cosine of theta. Cosine of theta is equal to the cosine of negative theta. And the sine, so that's even. The sine of theta is equal to the negative sine. I'm sorry, the sine of, yeah. So that's odd. Okay, and what that means is if it's even, remember, you can copy it across the y-axis, and if it's odd, it's like a reflective thing. Okay, so we'll see more of this when we graph the functions. We also want to introduce this idea of periodic functions. Okay, so a periodic function is when f of x plus p is equal to f of x. So if there is a p-value that exists, and this is for every x. So that's like any x value you put in there, this has to be true. So p is called the period of f, and an interval of length p length is a cycle. One cycle. So like when I say an interval, so like the interval 0 to p would be a cycle, or p to 2p, because these both have length p. Okay? So sine and cosine are not the only examples of a periodic function. You could have a function that, a function that's so here, the stair-stepping function. This is a periodic function. I just don't know the period, because if I take this value and I add p to it, I get the same value. Same here. If I take this x value and I add p to it, I get the same value. If I took this value and I subtract p from it, I get the same y value. Not x value, but y value. Okay? So it turns out that the sine and cosine functions are periodic with a period of 2 pi. So, what that really means is sine of, I'm going to change theta, my input variable, to t instead of theta. Sine of t plus 2 pi is equal to the sine of t. So, for example, and the cosine of t plus 2 pi is equal to the cosine of t. So like sine of, let's let t equal 0. So sine of 0 plus 2 pi is equal to the sine of 0. And that's true. The sine of 2 pi is equal to the sine of 0, because they both are equal to 0. So we would say that the sine of t and cosine of t are both 2 pi periodic functions. Okay, so we've got that the domain and range of both sine and cosine are, the domain is negative infinity to infinity. The range is negative 1 to 1. We talked about the zeros of each function. And we talked about how so if we look back at our unit circle, we can talk about the maximums and minimums of the sine and cosine function. So here, if we just look at these 4 points, remember this is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So if we wanted to find the minimums and maximums, like minimum and maximum outputs, remember the cosine is the x value, so the max of cosine theta is equal to 1, and the min of cosine is equal to negative 1. So right, because the biggest x value you can get is 1 here, and the smallest one you can get is negative 1 here. And that's the same for sine theta. They just occur at different points. So the maximum of cosine is when your angle is 0, or your angle is 2 pi, or your angle is 4 pi, or your angle is 6 pi, and then also negative rotations as well. The maximum of sine occurs at pi over 2, then 5 pi over 2. Every possible coterminal angle that is every angle that is coterminal with pi over 2 has gives the maximum value of sine. Okay, and we know that sine is an odd function and cosine is an even function, and they both have period 2 pi. So now let's graph our sine and cosine function. So let's first graph the sine function. So we're going to graph sine theta for one cycle. So in 0 to 2 pi. Okay, so if we make a table here, theta, and then sine theta, if I put in 0, I get 0, and this is looking at that table in the previous section, the unit circle table. If I put in pi over 6, I get 1/2. If I put in pi over 4, it's root 2 over 2. If I put in pi over 3, it's root 3 over 2. And the rest of this table is on page 561. Okay, but if you draw this graph from 0 to 2 pi, the sine, if this is 0, and then I make pi here, and then 2 pi here, so 2 pi, pi over 2, pi, 3 pi over 2, then the sine starts at 0, 1, -1, goes up to 1, back down to 0, down to -1 at 3 pi over 2, and then back up here. So, and then all these values in between. At pi over 6, it's 1. So it kind of makes this nice curve. There. So that would be the graph of a sine function. Okay? So this is a one cycle of the sine function. And it, like if you wanted to draw other cycles, it just keeps repeating this same thing. But this interval here is one cycle. Okay? So now if we want to do the same thing for the cosine function, I'm not going to draw that table, but if I draw the graph, 1, -1, the cosine function is a little different. Pi, 2 pi, pi, 3 pi over 2, pi over 2. So the cosine function, remember they're the x values, so it starts at 1 when your theta is equal to 0. When theta is equal to pi over 2, the x value is 0. When theta is equal to pi, the x value is -1, and back up. So it kind of makes this curve right here. Okay. So those are the graphs of the sine and cosine function. So you'll notice that I graphed what the book calls these 5 key points. So 5 key points. They are the x-intercepts, the high points, or the max and mins. So for the cosine function, I drew the minimum of -1. That's this point here. The x-intercepts are pi over 2 and 3 pi over 2, and the max values are 0 and 2 pi. So for the sine function, it's a little different. I drew the min values is the x-intercepts are at 0 and 2 pi and pi, and then the max value is at pi over 2 and the min value is at 3 pi over 2. Okay? So those are things you can look for when graphing the sine and cosine function. And then you can kind of connect the dots like I did when drawing these two sine and cosine functions. Okay, so now we want to talk about the amplitude. So if you have now, we're going to change this up. We don't just want to graph sine of theta and cosine of theta. We want to be able to graph like a sine theta and a cosine theta. So what does multiplying both of these by a do? Well, it would just multiply your output by a. So it shrinks how it shrinks and expands your range depending on what the value of A is. And we like to call A the amplitude. The absolute value of A is equal to the amplitude. Okay, so notice in this one, we have cosine of theta. We have y equals cosine of theta, so 1 star cosine of theta. So A would be equal to 1 here, so the amplitude is equal to 1. Notice that the amplitude is the distance between the maximum point and well, if you take the distance between its maximum point and the minimum point, so in this case it's -1 and 1, and you want to take half of that distance. So amplitude is 1 here. So if I were to graph, for example, y equals 3 sine theta, and y equals 1/3 sine theta. And we're going to graph this on 2 cycles, so -2 pi to 2 pi. We're going to put these two graphs on the these two functions on the same graph. So first let's start out with our plain old sine function. So if I go to -pi, -2 pi, pi, and 2 pi. So I'm going to go 1, 2, 3. -2, -3. Okay, so there's my coordinate plane. So remember the sine function, well, it starts out here at 0, and then at pi over 2 goes to 1. So right now I'm just graphing the regular sine function, just y equals sine theta. Okay, so this is y equals sine theta. So now let's graph y equals 3 sine theta. So this is going to change the amplitude. So what this 3 does is it's going to take the pi over 2 value, instead of being at 1, it's going to go up to 3. So, and it's going to go back down. The zeros will stay the same, but the amplitude changes. So this graph will look like this. Okay, and here we've got so this is the graph, y equals 3 sine theta. So multiplying, putting a 3 out there, stretched our graph up by a factor of 3. Now if we put a 1/3 out here, it's going to shrink it. So now if I mark this as 1/3 and this is -1/3, then it's going to go, whoops, that's a little too tall. Still cross at the 0. The zeros will be the same, except it's just going to be a lot, the graph is going to be a lot skinnier. I did not draw that correctly. In the y direction, or a lot, it's going to be compressed. So there. So basically what this number does is it stretches your graph in the y direction, or it can shrink it. Okay, but it doesn't move it to the left or right. It doesn't move it up or down, and it doesn't affect the zeros at all either, and it doesn't make it skinnier or wider. We will see what we will eventually see how to do those things though. But for now we're just talking about the amplitude. So this is the same thing happens if you if you do cosine, right, it just stretches out the cosine values. So I will skip the example of graphing a cosine, but it's exactly the same except you start out with the cosine graph rather than the this is the sine graph. If you wanted to graph a different amplitude of cosine, you would just take the cosine, the regular cosine graph, and then stretch it out by your amplitude. Okay, so next, let's talk about what happens if I put a y equals sine of b times x. Okay, so the sine of b times x, it changes your cycle to or changes your cycle, changes period from 2 pi to 2 pi divided by b. So let me show you why that is. So if I just consider y equals sine of bx with an amplitude of 1, if I were to put in x is equal to 2 pi over b, then sine of b times 2 pi over b will just be equal to sine 2 pi, which is equal to the sine of 0. So you can, all it does is just change your period. So that's where this number comes from. Because normally our period is 2 pi, but now if I have this b multiplied by here, you have to divide by b in order to get it, to make that your period. Right, so, or if I put in, right, so if I put in sine of 0, I still get 0 back, but if I put in sine of 2 pi divided by b, I get sine of 2 pi, which is 0 back. So the new period is 2 pi over b. So let's go through that with an example here. So let's graph y equals sine 3x, y equals sine of 1/3 x, and y equals sine x. So it's kind of similar to what we just did. And we're going to do it, well, we can't do it on, we're going to do it on one graph, but basically what happens is here's the normal. So if I do pi, 2 pi, I'm going to make that pi, 2 pi, 3 pi, 4 pi, 5 pi, and 6 pi. So I'm going to graph one cycle of each of these functions. So let's start out with the y equals sine x. So a cycle of that, remember sine, so sine starts out at 0 and has a cycle. Its one cycle length is 2 pi. So it goes up to positive 1 at pi over 2, down back to 0 at pi, down to negative 1 at 3 pi over 2, and then finally back to 0 at when theta is equal to 2 pi. Okay, so if I want to graph sine of 3x, the period is now, or the cycle length is now 2 pi over b, right? But b in this example is 3x, or is 3. So 2 pi over b is going to be 2 pi over 3. So it's like 2/3 pi, so it's like right there. So I need to graph this whole cycle. So this one right here is sine of theta, or I'm sorry, sine of x. X is what we're using. This one is sine of 3x. So the b value, what it does is it shrinks or expands your cycle length or your period of your sine or cosine graph. Okay, and finally, if I had 1/3, well, 2 pi divided by 1/3 is equal to 3 over 1 times 2 pi, right? Multiplied by the reciprocal, which is equal to 6 pi. So that means that the cycle length for sine of 1/3 pi is all the way out to 6. So the way you graph this one is, okay, well, so it would go up to 1 at, if the sine, pi over 2 is 1/4 of the way through the cycle. So 1/4 of the way to 6 is 1 1/2. So at 1 1/2 pi, it reaches 1. Then when it gets down to halfway, it reaches 0. The half of 6 pi is 3, just like half of 2 pi is pi. Then when it goes down to 4 1/2, when theta is equal to 4 1/2, it goes to -1. And finally, it completes the cycle by going back to 6. Okay, so the same thing is true for the cosine function. Okay, so some tips here for graphing sine and cosine. So with the change in amplitude and the change in B. So if we look at this nice table, this is on page 566. So if we have y equals a sine of bx and y equals a cosine of bx, where b is a positive number, then the period is 2 pi over b, and the range is -a to a. The one cycle is completed over 0 to 2 pi over b. Okay, so this is a nice table to see how these amplitudes and the b values change the sine and cosine graphs. So the reason they talk about a being positive and b being positive is because, well, if for example, if a were negative, you would just have to flip these graphs upside down and flip this graph upside down. Now, if b is negative, then we can use the values, the properties of the even and odd function. So if b is negative and you're graphing a cosine function, well, cosine is an even function, so cosine of negative bx is the same thing as cosine of positive bx, so you have nothing to worry about. But if you have b is a negative number in sine x, you can pull the sine of negative bx is equal to negative sine of positive bx. So that's how you can graph those two, if you have a and b negative. Okay, so let's do another example using this, we can use this table. So we want to graph y equals 3 times the cosine of 1/2 x. Okay, so first let's find the length. So first let's identify some things. So the amplitude, well, identify the amplitude and the period length. The amplitude is equal to 3, and the b value, or the so if b is 1/2, then we have 2 pi divided by 1/2, which is equal to 2 over 1 times 2 pi, which is equal to 4 pi. So this has got a period of 4 pi and an amplitude of 3. So if we're going to graph this, we need to make sure that we have enough room here. So since it's got an amplitude of 3, I need 1, 2, 3, 1, 2, 3, and -1, -2, and -3. And I also need to go from, so I'll call this 4 pi, this is 2 pi, 3 pi, and pi. Okay? So the cosine, remember, starts up at 3, starts up at the amplitude. Then at pi, I'm sorry, so first, actually, let's first draw the, we're just going to draw first the y equals just plain old cosine x. So if I draw y equals cosine x, remember it starts up at 1, then at pi over 2 falls down to 0, and then at pi it goes down to -1 for cosine, and then up back to 0, and then up back to 2 pi. And then it repeats itself like that. Okay, but I only wanted to draw one cycle. So now if I wanted to draw cosine of 3, or 3 cosine of 1/2 pi, these points become stretched out. So like the 5 critical points, so if I plug in x is equal to pi, I get 1/2 times pi, and the cosine of pi over 2 is 0. So it starts up at 3 and then goes to 0 at pi. So there's your first one of the 5 key important. So there's the maximum, a high point, and a 0. And then if I plug in 2 pi, I get 1/2 times 2 pi, or just pi, and we know that the cosine of pi is -1, so cosine of pi would be -1, and then we multiply by 3, so you go down to -3 at 2 pi, and then back up to 3 pi, and all the way up to 4. Right, you can always, so just plug in if I want to show you guys another thing about this table here. So if I look at this picture of the cosine graph here, the amplitude goes up to a. In our example, a was 3, and goes down to, its minimum is at -a. And then pi divided by 2b, that's the first 0. Remember, b is 1/2, so pi over 2 times 1/2 is just pi, so that's the first 0, which is what we had. And then pi over b, pi divided by 1/2 is the same thing as pi over, or 2 times pi, so 2 pi was our -1, or -a value, and then another 0, and then finally back up to the positive a amplitude. So you can use that table to help you graph sine and cosine functions. Okay, so now we're going to talk about how we can, so we've learned how to stretch the graph in both the y direction and the x direction, but now what if we want to actually just move it? So for example, this graph you could cut it in half along the x-axis, and we want to learn how to move it to the right and up and down, move it to the right and left and up and down. So first we're going to learn how to move it left and right. So this is called a phase shift. Okay, so this is where you get, the phase shift comes from y equals a times sine of x minus c. So remember, so let's just, as an example, let's just graph y equals sine of x minus pi over 2. Okay, and we're going to graph y equals sine of x, just to compare. So and we're just going to do one cycle. So the period of both of these is just 2 pi. If you wanted to change the period on this, you would multiply a number right here, but let's just stick with this example for a second. Okay, so we have a 1, -1. And if I'm going to graph y equals sine x first, so we got a pi and a 2 pi. 3 pi over 2 and a pi over 2. So we know what this one looks like by now. So that's y equals sine of x. So now let's take a look at this y equals x minus pi over 2. So just like when we had the exponential, we're learning how to add or draw the exponential functions and logarithmic functions. If I input x minus c, that moved it c units to the right. Well, it's the same for the trigonometric function. Yeah. So, for example, if I plug in pi over 2 here, it's sine of pi over 2 minus pi over 2, or sine of 0. So that's 0. And if I plug in 0 here, I get sine of negative pi over 2. The sine of negative pi over 2, if I draw my unit circle here, draw it down here. So off to the side. The sine of negative pi over 2, remember negative pi over 2 is this angle right here. And the y value there is -1. So you have, it's coming up like this. And then if I plug in pi, I get sine of pi minus pi over 2. So it's pi minus pi over 2 is pi over 2. And we know that the sine of pi over 2, the y value of this angle here is +1. And now if I plug in 3 pi over 2 minus pi over 2, 3 pi over 2 minus pi over 2 is just pi. And we know that the sine of the y value here is 0, so it goes back down to 0. If I plug in 2 pi, it's 2 pi minus pi over 2 is 3 pi over 2, and we know that that gives you back a -1. And then if I go up to 5 pi over 2, if I plug in 5 pi over 2, 5 pi over 2 minus pi over 2 is 2 pi, so it goes back up to 0. So this one is the sine of x minus pi over 2, and this one is the sine of x. Okay, so we can see that this graph here is just the sine of x shifted over to the right by pi over 2 units. So that's called a phase shift. So, if you want to combine all the three things we've learned together, the horizontal stretching and the vertical stretching and the phase shift, your functions will look like this. Y equals a sine of b times x minus c. Okay? So, the c moves. This is the phase shift. This is the horizontal stretch, and this is the vertical stretch. Okay, so let's do an example where we have a value for all three of these things. So if I wanted to graph y equals 3 times the sine of 2 times x minus pi over 4. I first need to figure out my a, b, and c values. So a equals 3, b equals 2, and c is equal to pi over 4. So it's going to be shifted to the right, pi over 4 units. Its period is going to be 2 pi divided by 2, so period of pi. And it's going to have amplitude of 3. All right. So we start our, if we want to graph one cycle of y equals 3 times sine of 2 times x minus pi over 4, we want to start our cycle begins at our first phase, our phase shift. So you have pi over 4, and then our period plus our phase shift. So pi over 4 plus pi. Okay, so this is the same thing as pi over 4, comma 5 pi over 4. All right, so let's draw our graph. So we need, if we have, let's see, we need pi over 4. And then another thing you can do is you divide this interval into 4 equal parts. So pi over 2, 3 pi over 4, 4 pi. 4 pi over 4 is just pi. And then finally 5 pi divided by 4. 1, 2, 3, 4. 4 equal lengths. And these actually are where those 5 points occur. Like those, right? So we're drawing a sine graph, so we know that when our cycle starts, it starts at 0. And then when we go up to our next, after we've divided our cycle interval into 4 points, or 4 intervals with 5 points, the next one for sine, if you have a positive amplitude, so we need to go up to 3, 1, 2, 3, and graph the 3, then go down to negative 3. And we get a 0 here, since it's a sine, and then negative 3 at pi, and then back up to positive, or back up to 0 here. Okay, so again, to illustrate this process, you first figure out what your amplitude, your period, and your phase shift are, and then you create your cycle interval, which is just the phase shift. It starts at the phase shift number, the c equals pi over 4, and then you add to your phase shift the period. Okay, so that's our interval that we have. Then we're going to take this interval and divide it up into 4, divide it, so you want to graph these 3 points in between these last 2 points. And that takes it, if you divide your period by 4, right, so pi over 4, and you add it to the left. So pi over 4 plus pi over 4 is pi over 2. Pi over 2 plus pi over 4 is 3 pi over 4. 3 pi over 4 plus pi over 4 is pi, and pi plus pi over 4 is 5 pi over 4. So those are the 5 points that you will always need for sine and cosine. Then, since we have a sine graph, we know it takes this shape, rather than the cosine graph starts up here, goes down to 0, goes down to negative 1, goes up to 0, and goes back up to the amplitude. Okay? Then you mark out what your amplitude should be, and you determine if it's, right, you have to always know if it's a sine or cosine graph, and then you know the general shape of both of them. Okay. All right, so let's continue. So let's go back to the point I was making about what happens when your b value is negative. Well, then we use the sine and cosine. So like if you had, or we use the even and odd properties. So if y is equal to a sine of b times x minus c, where b is negative, well then, because sine is an odd function, this is the same thing as negative a times the sine of the absolute value of b times x minus c. So when you have a negative out in front of your a, all you have to do for the sine graph, and the cosine graph that is, where's the one I just drew? So when you have this negative out front here of a sine graph or a cosine graph, is all you have to do is you take your graph and you flip it everything. So if I wanted, so here I have the picture of y equals, remember it was 3 times sine of 2 times x minus pi over 4. So this one is y is equal to 3 times sine of 2 times x minus pi over 4. So what if I wanted y equal to negative 3 sine of 2 times x minus pi over 4. Right, so you still start at 0. Negative 0 is still 0. But now instead of going up to positive 3, right, if I plug in pi over 2, I get pi over 2 minus pi over 4, which is pi over 4, times 2, which is pi over 2. The sine of pi over 2 right, so let me restart here. So if I plug in pi over 2 for x, I get pi over 2 minus pi over 4. Pi over 2 minus pi over 4 is pi over 4. And then I'm going to multiply it by 2. So you get pi over 2 inside this sine function. The sine of pi over 2 is 1. And then I multiply it by negative 3, so this goes down here. So it goes like this. And then for the same reason, you come back up to 0. And then the same exact reasoning, if I plug in pi here, I get pi minus pi over 4, so that's 3 pi over 4. Multiplying at 2 is 6 pi over 4, or 3 pi over 2. 6 pi over 4 is the same thing as 3 pi over 2. The sine of 3 pi over 2 is negative 1, but now I'm going to multiply it by negative 3, so this becomes a positive 3. So you go up to here, and then back down. So this one right here, that's all you have to do when you have a negative out front is just flip it over. Okay, so that's how you would deal with it if you have a negative number here. So if you had a cosine function, the beauty of it is, if b is negative, because it's even, remember cosine of x is equal to the cosine of negative x. So it's the same thing as a cosine of absolute value of b times x minus c. Okay. So for example, if I had y equals 2 times the sine of negative 2 times, let's just do negative 2 times x. So I'm going to identify my values here. I have a is equal to 2, b is equal to negative 2, so we have a negative b value, and c, the phase shift, is equal to 0, because this is negative 2 times x minus 0 technically. Okay, so we have a negative b value. So if we have a negative b value and we have a sine function, we're going to graph, this is the same thing as negative 2 times the sine of absolute value of b. The absolute value of b is positive 2, sine of 2x. So this is something we know how to graph. So for this one, we're going to graph negative 2 sine of 2x. So a is equal to negative 2, so that means the amplitude is equal to 2. the amplitude is always the absolute value of A. B is equal to 2 and C is equal to 0. So I just have to take this. I learn that the period is equal to 2 pi over B, so that's equal to pi. So now I can graph my function. So this is just, remember that, so it's a sine function, so we know it takes the shape where it starts at 0, goes up to 1, back to 0, down to -1, and over to back to 0. Well, up to its amplitude, down to its 0, down to its negative amplitude, and back to 0. But that's for a positive sign. So now I have this negative out here, so I have to flip it over. So this is going to start at 0. And remember, the period is pi, so the interval of the cycle is 0 to pi. I start at the phase shift, 0, and add the period to it. And if I divide pi by 4, that's pi over 4. So I start at 0, add pi over 4, add another pi over 4. So pi over 4 plus pi over 4 is pi over 2. Add it again, 3 pi over 4, and now I'm back at pi. So there's my 4 intervals and my 5 key points. So I see that the amplitude is 2, so I need to go up 2. So now, because I have this negative out front here, I need to flip over my graph. So instead of going up to positive 2, I need to go down to negative 2. So this is going to go right here, up to 0. Since it's a sine curve, up to 2, and then back down to 0. So that's how you would graph. We started with 2 sine of negative 2x, and we used the fact that sine is an odd function. So we pulled the negative 2 out. Then we figured out that our amplitude is 2. We have to flip our graph over because of the negative. And then the period is pi, and the phase shift is 0. Okay. So something else they might throw at you